Hi, I'm Taylor.
Hi, I'm Ashlyn.
And recently we're two moms who lost their son due to a disease we had no idea existed.
Called Potter syndrome. We decided to do some research and meet with new doctors as well as old ones who helped us in the hospital and try to figure out how to increase the survival rate.
We get a close up on the baby. Okay.
As you just saw, our son was born on May 10th, 2025. He was a preemie born at 26 weeks. When he was born, one doctor took one odd look at him, called a few others over, and they told us they need to examine him further.
We were already a little worried due to the fact Chandler didn't come out really screaming or crying. He also had a bit of a trouble breathing, the doctors were quoted saying. And then when we got a close look at him as we held him, we noticed that he had kind of spaced eyes, his nose was a little off, and his ears were lower than what you would expect.
The doctors were very worried about our boy, so they decided to take him back for a few more tests.
At the time, we didn't know what the tests were, but now we do. They tested his electrolyte panels, as well as compared that with the results of his Apgar test. And due to the findings being a little iffy at the time in those results, they also proceeded to take ultrasounds and double-check that if what they were kind of hinting towards and thinking was accurate. So now, fast forward to today where we currently are. We recently received, after a couple interviews with the doctors and everything, we received Chandler's case file. So sadly, Chandler passed away 3 days after he was born. They kept him on dialysis and oxygen, and with the disease that we didn't know about at the time, the survival rate wasn't really high nor expected. So the results of which are right here. So the Apgar test was low. As you can see here, he scored zeros, ones, didn't make it to any of the two categories. And as well as that, the physical examination paired with this is what then led to the ultrasound right here. So with that being said, we then were a little concerned because now he's in the NICU. He's 26 weeks and he's preemie, and we're a little stressed. So we asked, what are you guys thinking it is? What else do we need to take? And they decided to do a few more tests.
They took him back to do an electrolyte panel, and his tests were abnormal.
So with the results from the test, as you can see here, paired with the physical examination, all of his electrolytes, his sodium was high, potassium was high, chloride was high. Protein levels were off.
His serum creatinine high level of creatine in the blood indicated poor kidney function.
So that was the big thing, is due to the high protein in his blood,
he had poor kidneys.
Yes, so that was our first indication, but this was after we compared all of these findings and all of the tests, the doctors discovered Potter syndrome, which is what we mentioned before. So Potter syndrome is a disease of which the baby is born with no kidneys. And the survival rates for this is zero, like very non-existent. It was shocking to the doctors that he even lived 3 days, let alone, at all, that he came out of the womb and he
alive.
So with that, we were really, shocked because we had no idea, what is this? How did he have this? Why didn't this come up during all of our checkups? Every time we went to see, it was happy, healthy heartbeat. There was no indication of our baby being born without kidneys. And to give you a further example of what Potter syndrome really is, we'll show you a diagram of Chandler. So as you can see in Chandler's diagram, this is a set of kidneys.
And he does not have them, as you can see.
So when he was born, so this is just a little bit of a physical demonstration of what this is and how our baby didn't have any.
And as you can see, this is an abnormal set of lungs, so smaller than what normal lungs look like.
And the blue one is the one that Chandler has. So to better give you a demonstration of what his lungs look like.
So he had smaller lungs than what a normal baby should have.
Due to Potter syndrome. So this conclusion was resulted from, at first, the physical examination, which then we now know is called
Potter's facies.
So Potter's facies was the spaced eyes, the flattened nose, the lower ears. So the physical examination is what caught them off guard initially, as well as the respiratory issues, which is how Ashton just explained that his lungs were smaller. So obviously that and the breathing issues reported on Apgar test, it was obvious something wasn't right with him.
After his passing, me and his mom were very heartbroken. We decided to dig a little deeper into ways for survival to be more efficient. We met with many professionals, those including...
Hi, I'm Anna. I'm the OBGYN.
Hi, I'm Molly, and I'm the neonatologist.
Hi, I'm Stacy. I'm the pediatric nephrologist.
Hi, I'm Lily, and I'm the pediatric pulmonologist.
Hi, I'm Amanda. I'm the pharmaceutical scientist.
As you just saw, those are all the doctors that we got the privilege to meet with us and talk about our son.
So after we met with all of them, we wanted to get a little bit of a better understanding of our results and of ways to, better, as we mentioned, better increase the rates of survival. And we came up with two brand new ideas, one being a medicine and one being
The idea with this medication is that it will make up the job for the kidneys, see the kidneys filter out waste products, specifically the urine creatine, in their absences. We need to find another way to filter out these waste products. Ren medication is just the perfect solution. The medication is split up into two jobs. The first job is reverse creatine reaction, where the synthetic myocycles, are also known as muscle fibers, are built up. The second part releases an enzyme called urease. The urease is filtered through synthetic muscle tissue and broken down into ammonia and carbon dioxide.
So now a visual for this of what the medicine would look like as a rough draft, because obviously this doesn't quite exist yet. This is just our ideas and, what we've been thinking after meeting with our scientists and all of our pediatrics. So basically just, split in half, a bit of an example of how the bloodstream and then the muscle tissues, and then that's going to filter out, leaving those enzymes. So just making up the job for the kidneys practically synthetically. So it's just a fake way to have the body not know the difference of the kidneys being absent, but everything that the kidneys do in their job is still being done. Now, the second thing we came up with was a in utero renal support module. So now this module is also synthetic. So it's a membrane, a filtration interference, because that's what the kidneys do, filters out all the bad and gives us the good, attached to the umbilical cord and mimics the basic kidney functions. Getting rid of waste and the electrolyte balance in coordination with the placenta. So now this would allow some management of the uroemic toxins and fluid balance, so that imbalance that we see in the bloodstream and, what causes the baby to not be as healthy would be cleared and taken care of. As well as biometric fluid centers that would monitor the fluid composition and fetal movement. So this would be while the baby's in the stomach. So this is a process that would happen while someone is pregnant, while the medicine is something that, the babies or anybody would take after. The medicine, so there's two types, so, pre and then post. So back to the biomedical fluid centers, this is just the composition in these, of creating the synthetic atomic fluid electrolyte balance. So what's absent, the reason that the lungs are developed is because of the lack of fluid, and that's what the kidneys are responsible for. So basically how this works is it'll be implanted in between the 18 to 22 weeks gestation in case it's diagnosed. So this is when we have to pay a little more closer attention to our ultrasound results, where in our case sadly didn't happen and we weren't able to catch this early on. And it'll maintain the consistent atomic volume to prevent pulmonary hyperplasia, underdeveloped lungs. That's what's considered the most fatal aspect. So that's what's really big here, is the respiratory system is so affected due to the absence of the kidneys, is 9 times out of 10, not in our case, but in other cases as we research, is that's what it is they simply cannot breathe. And then the system will interface with fetal circulation to assist the basic fluid waste removal. So as the kidneys remove waste, this is just yet another synthetic way for that to be done. Potential impact of this, when we met with our pediatrician and our neuropulmonation, met with our nephrologist, we also realized that improved lung development, reducing neonatal mortality from pulmonary hyperplasia, as well as the extension of pregnancy duration, enabling better survival rates so the baby won't be preemie like it was in our case, as well as a bridge to neonatal dialysis or kidney transplant after birth. So this just makes the survival rates skyrocket, which was really awesome to see after meeting with our neonatologist. She broke it down really simply to where it's just a better rate of survival for the baby, and that an implant like this, like even though it's synthetic and everything, if it were possible and could exist, it would be life-changing. So after Chandler's death, as you just saw, after, you know, all of our new medicines, we decided to go back. So through this process of creating the new medicine and creating the transplant, we decided to go back to the doctors and visit the idea of what happened, like what caused it. And what we found was it was in fact genetic. So the likelihood of it being genetic is rare and slight, but it is possible. So as you can see here, these are the gene tests. So like I mentioned before, of the GRIBL and then the GF20 genes, it was in our case that. And looking back at our pedigrees and everything, we both have the carrier. It was just a simple malfunction in rearranging of the genes. As you can see here, the sequence was all messed up. So, you know, we discovered that the hard way after he had passed and the doctors took that test. But you know, it's something you can't really control. That's just the way the body is developed. So
As sad it is that we lost our baby, we did learn a lot about Potter syndrome to help future mothers.
and that was the whole goal of the entire thing, you know, the case files, all the tests that we went through. I mean, in our case, it sucks. But now when 2 other new parents run into this, they're not going to have this issue. And the goal is to save more lives. So we learned the hard way about it, and it really sucked, and, you know, it's sad, but
We did help futures.
yeah, we helped develop new medicines and new transplants and all of these ideas. I mean, those were only a couple that we showed you. There's so many more opportunities and ideas for us to, you know, hopefully never run into this again.